How's it going, everyone? Welcome, Elvier Gonzalez here. I'd like to explore in today's video about the React stuff, especially how you can work with different inputs. The most common one, so checkbox, radar button, select, and the input type, text, password, cell, and range. All of this, the last one, they works the same, right? But and also with the select as well as the text area. However, for radio buttons and checkboxes, things are a little bit uh, things get a little convoluted. Why? Because now you don't have a unified way to bind data and get it from. So this data binding is particularly to radio buttons and checkboxes. And into this video, I want to now recreate this from scratch. So not only from the React perspective of how you can write this user interface, but also how you do that without it, right? Because I do think that a lot of people out there, and again, I generally don't care about other people's, but I do think that uh, there is a trend of not knowing what the thing is doing, especially when you're writing its user interface, which is just simple HTML tag that you can pull out of this pool of inputs, and you can work directly with them. And now things are not that complicated as it used to be, and there are some particular way of how you can make it easy when you understand now, for example, functional programming and object programming and so on and so forth. But again, the TLDR is that how you do that without React, which is the old way of doing things, or the traditional way of using HTML, CSS, and JavaScript to write UIs, and now with React. All right. So here I define is this, right? So I define is a form that will have now a field set that is say, hey, this. I'm not sure if, for example, other how do you call it? SHA CDN UI actually have that, right? This is the fundamental design system. So you get this. For example, if you want, it's interesting because most of the time those field set, you don't have them, right? But again, it exists. So you have field set, you know, wrap your array field in a field set or field legend. Okay, so if you take a look at the field, the component, so you get this, but it's interesting because you don't see is that field by the, again, all of these are specific UI elements, right? That if we inspect a little bit this, so you have now each one of them, you have, this is a legend, an HTML element, and also the field set, you know. So behind the scene is using, now you have a field group, which is a field set, and then you modify is the layer for that, you know. This is a field set, but at the end of the day, that's exactly what they're using behind the scenes, you know. So they're using now this field set with this fancy React component. Okay, this is a field set. What I'm gonna put is now the legend of this field, right? Some paragraph about it, and then now the this input field, or the field group, right? Which is just a collection of two elements here. is the label, and it is input, right? Again, this is just a fancy way to get this kind of user interface. But at the end of the day, behind the scenes, that's what they're using, right? So this is what we are recreating here. So this is a field set. By default, the UI in most browsers is to wrap this in a box, and using the legend to define is the name of this field set. And then you describe now your input groups, right? Or your field group, whether it's by the, in our case, with checkboxes. So I define here is a group of this in a check, or in other words, as an input and the label, right? And the input at a label and input at a label. So if you want to let the browsers, so for accessibility, if you click on the label, it should actually automatically check box that, or tick it, tick in or out. So the thing here is, if you now to achieve this behavior, you just put an ID to the label that match with the input, which is exactly what I did here, right? Particularly, label use the form, right? For, but in React use now the HTML form. But in any case, this is how I create all of this. So I just want is to get rid of all of this, all right? And try to recreate that specific behavior as it is, right? So I do need to somehow is to show this piece of information. So let's gonna call this the same as we have here, all right? As the anchovies, and exactly like this. You call here is pizza toppings, all right? And this will be now the object that is going to hold this piece of information. Anchovies set to false initially, and the chicken sets to false, and tomatoes sets to false, right? And what's next? Well, I would like to here's the thing, we are now in the land of JavaScript, so you can do whatever you want. So I'm going to lay out what I'm going to do here, and what are the things that need to do, what are the problems here. And that is, hey, how can I now not only, so let me fix this straightforward issue. How can I first show, because again, this is the UI. How can I first show this content, and then how can I provide this interactivity to this, right? And then how can I is bind this data to the object here. So three things here: the UI, the object UI, the inputs UI to actually work as expected, and then the data binding. Three main problems here. Okay? All right. So let's start with the first one. And that is, hey, how can I show this? Or in this case, I can get this element and then show that, right? So by getting this element here, I can say, hey, whether you're using get element by ID or the query selectors, what will be the difference between one versus the another? Okay, that's a good question. All right. And I can ask Claw here a little bit. I have three problems to solve, right? So first is show the pizza toppings. Okay, I have three problems to to solve. Show pizza topping object in the on the state displayed. All right. So on state display, on a state display here, show the pixel topping object on state display ID element. Figure it out. What is the most performant way to do it? Right? No, stop it, 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 stop it. Conversation was not found. Okay, makes sense. Right? Okay. Okay. Chill. Chill. Get rid of that. There you go. 1. Show the pixel topping object and display the element ID. And here I say, hey, 1.1, figuring out what's the most performant way to do it. Right? That's the whole point why I'm getting paid for, to make the things fast as possible. And yeah, the second problem is that I really fixed that. The second issue is the data binding. Okay, how can I or what are the alternative to data to do data bindings for or to do data bindings for pixel topping? Wait, what? I don't think he. Okay. Okay. No, you didn't copy that, right? Okay. Now you do. You got it. This is one. So I have three problems to solve. First, show the pixel topping object on the state display. ID element, figuring out what is the most performant way to do it. What are the alternative to do? What are the alternative for data binding between the pixel toppings object and the checkbox inputs? Right, and here is this. What are the alternative? So what is exactly, what is the most performant, or what is the convention? What is the conventional way to do it? Right? According to the ecosystem. So what is the most performant way to do it? Right? Let's get into this. I'll help you solve both problems. First, I noticed a small bug in your code. There's a typo, miss pizza topping and pizza toppings, pizza toppings. An object use semicolon instead of commas. All right. So exactly, the most performant ways to show something is to now bind that element. So get that element there, and now the content of that box is gonna be this, which is transform that object into a string, and this is the proper format that I want to provide here, right? With the white space. So this is something that is quite fast. Single done right operations. Text content is faster than in an HTML. No HTML parsing. And JSON to stringify is native and highly optimized. Okay. Alternative, more readable but slightly slower, is this. So you're going to now map over all of this element, create now this key value pair as a string, and then now what you're doing here is just parsing that, is parsing that object into a string, right? But this is at the end of the day, you are parsing that object into a specific value type, which is the string. All right, that's the value that there that content can be rendered as a string. All right. And then you have now data bindings alternative, event delegation. All right. So when that happens, you want to upload that. Only one event listener, minimal memory, and scale well with many checkboxes. Best for dynamic content. And then you have individual event listener per input type, right? Okay, event delegation. Here we are. Okay. Event delegation. Okay. When this specific elements detects this, when any of these elements change, it's going to verify if that is a checkbox, and if it is, run this. Okay, event delegation. The other is the individual event listener. Very straightforward, negligible performance different for 3 items, and good for static content. And the other is a proxy-based reactivity, the motor approach. Okay. So here you create now a proxy that when those properties change, all right, you're going to now update that property with the value that you're receiving, and then runs that. Automatic updates on any change, clean separation of concern, and framework like reactivity. The other is a two-way binding function, where you say, hey, bind checkbox ID and object keys, update object when checkboxes change. So you are okay. So get that element. So get that checkbox. Attach now a function listener to this. All right. And then now update the property. Update the property here. Update checkbox when object change if needed. Performance comparison, event delegation. Whether you're using is event delegation, but again, you know what? My recommendation for your case is using event delegation. It is more maintainable, and if you add more toppings, single point of control, and model best practice. Mm-hmm. That is interesting. Okay. Okay. This is why I actually. Okay. 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 Mm-hmm. Mm-hmm. Makes a lot of sense. Okay. All right. All right, Claw. Now, let's do this. Let's do this. Um, do a research. All right. Do a research about this. Uh, do a research about this. Um, so check your findings from check your finding from standards, from industry standards, spec, industry standards spec. Check your finding from the industry standard spec. Let's get into this. Okay. It's not a trivial thing, and this exploration is part of the understanding what are the problems that you're solving. Yes, understand these kind of problems. Mm-hmm. Mm-hmm. Event delegation. All right. Event delegation or proxy base, right? So the event delegation is great if you dynamically add elements to this, because you have one single source, or you have one single source of control, all right? And no matter which elements, how many elements you do that, you capture that, and then you update that, you mapping that. So far, so good. The other approach is from the object line. Okay, okay, okay. So there are now two alternatives here of how you can respond to events. Okay, how you can detect event change and update the data to that. Holy moly. All right. Okay. All right. Mm-hmm. 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 That makes a ton of sense of why we are doing this. All right. So let's go with the simple one, which is rendering this uh, data here. Okay. This is interesting because I also looked at template is one way to do that. So with template MDN, content template element, you say, hey, browser, please hold this HTML fragment that it can be used later via JavaScript or generated immediately into Shadow DOM. Right? Usage notes. This element has no permitted content because everything nested inside in the HTML source does not actually become the children of the template element. But you can use that. Okay. So you can use the template as a container. Okay. So you can use a template as a container. Existing data could optionally be included here. And then you say, hey, template ID product row with this one. First, we have a table into which we later insert content using JavaScript code. Then comes the template, which describes the structure of the HTML fragment representing a single table row. Now that the table has been created and the element and the template defined, we use JavaScript to insert rows into the table, with each row being constructed using the template as its basis. So to test to see if the browser supports HTML template by checking for the presence of the content attribute. Okay, let me see if the current browser actually supports that template. If it is, now I'll query that element, get me this element, the body and the template, right? Clone the new row. Okay, clone the new row and insert it into the table. So I'm hearing is to clone this and insert, so create a copy of this, of the template, right? And then on the clone, insert some content into that. Okay. And then after that, you're going to now append the clone with this new data to this, right? And clone the new row and insert it into the table. So you're creating is a new row. To clone that, right? You modify. So once you have that cell, select that cell, update its content, and append that. So the result is the original HTML table with two new rows appended to it via JavaScript, like this. Exactly. So you have now the first one and the second one with stuff, and the first one and the second one with this, right? Implementing a declarative shadow DOM. In this example, a hidden support warning is included at the beginning of the markdown. This warning is later set to be displayed via JavaScript if the browser doesn't support the shadow root mode here. So the first style element is global to the whole document, and the second one is a scope to the shadow root generated in place of the template element because of the presence of the shadow root mode attribute. So you get this. This is hidden. This is the article. And this is another article that inside of this you have is template here, right? So is shadow root mode supported object.has on to do. So I am in the DOM, I am in the shadow DOM. Okay, declarative shadow DOM with delegated focus. Oh, and again it is data on the document fragment is not cloned. Click this div, click this. Okay, and it was somewhat introduced to the template here. See also slot in HTML has a slot, host, and host context. Bar and slotted. Shadow root interface using template and slot. CSS scoping models. Okay, this is part of that. But again, why do we even have this? Why in the first place we need to have is template, the content template elements. Your JavaScript DOM performance research is ready, right? So the syntax error on semicolon versus comma is object literals, no problem. Display the object state. Text content wins decisively. For updating here, text content is fastest. It's X safe because you don't inserting anything. It's just string. Is 15% slower. And is excess vulnerable, and only with sanitized HTML. Exactly, because here you are now is parsing HTML. Okay, makes sense. And the other is inner HTML. slowest, XSS safe when CSS visibility matters. The performance gap exists because text content skip the HTML parse entirely, while the inner HTML must part the string even for plain text. MDN docs. More critically, inner text triggers a browser reflow to compute style, an expensive operation that text content avoid completely. Optimal implementation to do this data binding. V8 JSON Stringify has heavily optimized with sim instructions and achieve approximately 3 million operations per second for small object. 3 million operations for small object. How we make JSON Stringify more than twice as fast? 2025. Holy fuck! Oh my god, that's new. How we make JSON.stringify more than twice as fast. JSON.stringify is a core JavaScript function for serializing data. It is performs directly affect common operations across the web, from serializing data for a network request to saving data to a local storage. A faster JSON Stringify translates to a quicker page interaction and more responsive application. That's why we're excited to share that a recent engineering effort has made JSON Stringify in V8 more than twice as fast. And this post breaks down the technical optimization that made this improvement possible. Optimizing string serialization with sim. Okay, what is sim? What sim stands for? For longer string, we switch to dedicate hardware sim. Okay. Oh, I get it. Sim instructions. Okay. Single instruction, multiple data. Okay, single instruction, multiple data is a parallelist technique at a data layer. Okay, so AMD and 3D Now and SSE from Intel, Siglog 6080. Okay, but they decide to use now that instruction. Okay, this is a low level features. Let me switch to English. Sim pronounced Cindy. Cindy. Cindy? SIMD is short for single instruction multiple data, which is one of the classification of computer architecture. Here we go, bro. Classification of computer architecture. Flynn taxonomy. Holy hell. Alright. It's a classification of computer architectures proposed by Michael G. Finn. Holy moly, sir. My respect, bro. My respect. Flynn proposed Flynn taxonomy, a method of classifying parallel digital computers. Parallel digital computers in 1966. Parallel digital computers. So you have a computer, a system to compute, to process something, and you want to classify is this kind of system that can parallelize computations. All right, okay. It's a taxonomy for parallel digital computers. Holy fuck, okay. Parallel digital computers. Parallel digital computers, bro. Parallel digital computers. SIM. Anyway, simultaneous pipeline processing. And Flynn, 1962. 1972, pipeline processor, stage delay execution, and edge state dedicated resource. So etc. multiply add, and with sim you have now M-way simultaneous pipeline processing. So instead of pulling all of it in a queue, they have like one single queue, so one single instruction that is going to be processed. Okay. This might go beyond the scope of today's video. Oh my god, we're getting deep, bro. SISD instruction pull, data pull, and then you get is this. So given the same data pull, you have now this, what PU stand for? Each processing unit. Okay, given the same memory pool, you're going to now pass some processing units, or in this case, the processing unit is going to look at the instruction pool and the data pool. Again, this is the diagrams comparing classification. Okay, this is for describing. Describing a different ways of how digital computers can process. Okay, holy moly. How digital computer can process in parallel. All right, this is the most straightforward. So you have one single unit that is look up for instructions. So what needs to do and what with what. Okay, what needs to do and with what. A processing unit. What need to do and what I have. And then you have this. Okay, and then you have now this. In 2006, all the top and most top 500 supercomputers are based on MIMD architecture. Although these are not part of the Flink work, some further divide the MIMD category into two categories below, and even further subdivision are sometimes consider this. Multi-programs, multi-data stream. Okay, so the TL of this is you have now a way to classify computers architecture, how you organize computers to do parallel stuff, to do things at the same time, to do a lot of things at the same time. Okay, it's a classification of computer architecture proposed by Michael S.G. Flynn in 1960 and extended in 1972. The classification system has stuck and it has been used as a tool in the design of motor processors and their functionality. Design of motor processors and their functionality since the rise of multiprocessing and central processing units. A multi-programming context has evolved an extension of the classification system. Vector processing, covered by Duncan's taxonomy, is missing from Flink's work because of the Cray 1 was released in 1977. Flink's second paper was published in 1972. The four initial classifications defined by Flink are based upon the number of concurring instructions or control stream of data available in the architecture. But again, the TLDR of all of this, all right? The TLDR is that this is a classification for computer architecture, how you organize different pieces to make that system, that organization, compute stuff in parallel. All right. An example of this is how you can now if you have if you have a team, if you have a team, mm, 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 so imagine that you are a sport coach, right? If you're a sport coach, if you're a sport coach with 12 small kids under your command, right? So you want to get the best out of them in soccer or in football, right? So you are now going to identify each one of their own traits, right? And then try to make them more aware of their abilities, and therefore uh, make them do stuff that are not used to, but that are need for the task to play football. In this case, let's say you have from 12, three of them are great candidates to be captains. Five of them are great to be archers, right? And some others has now inclinations to not be a good deal, right? They need to have a lot of work to do. Um, so if you're in that situation, right, you want to, of course, parallelize what they are doing from your standpoint. Hey, I want these three kids that are potential captains, lead the team. So you switch from one soccer game to another one, right? These other folks that are more likely to be archers. So you want to swap which one of them are fit for that in different games and in different environments. And the other is the rest of that, right? So you want to play where they can be fit in this spot and so on and so forth. So this is now parallelization from the coach perspective, all right? And in the case of computers, now if you have several machines or robots doing your bidding, imagine that, hey, okay, now things getting interesting. Um, because imagine that you have now several air fryers to cook to cook some beef. So I do want to cook a roast beef and then the salads, and I have several of these machines. I I set a schedule for how long I want you to. I want to set a schedule. I want to set a schedule for how long they need to cook, the starting point, and so on, so the stuff, right? But I do find this very interesting and appealing. Holy French toast. Okay, so this single instruction multi-data is one classification of computer architecture. Seems alone one safe operations to be performed on multiple data points, resulting in data level parallelism. Okay, the same operations to be performed on multiple data points, or aka parameters. Mm-hmm. Resulting in data level parallelism and thus performance gain. For example, for 3D graphics and video processing, physics simulations or cryptography, and others domain. So hey, I have this data, right? 3D graphics, video processing, physics simulation or cryptography, and I want to apply the same since I want to do this same operation, so I parallelize that, right? So I parallelize that data for one single instruction. See also this SESISD for a sequential architecture with no parallelism in either the instruction or dataset. SISD. like this. Okay. Holy moly. So in other words, they're using is the same string. Okay. So in other words, they're using is the parameter, in this case, the string, the entire data set. All right, and a string can be this word or this another one. And for the sake of example, I'm going to use this optimizing here. So you have now the word optimizing here, all right? And for each one of those data points, aka parameters or data values, right? Letters in our case, you are going to pass down to a specific processing unit, right? To apply that single instruction, the same instruction. Oh, okay. Okay. Let me see if this is what it is, you know? Let me see if this is what it is. So, SIMD instructions is a way to organize computer digital computer systems. Okay, so SIMS instructions or SIM architecture, because it's this. All right, SIM is a way to organize digital computers for data parallelization, for computing, for for com- for processing, for processing, for processing, for processing computing. It's a way to organize digital computer uh, for parallel for for parallelization, or for, yeah, for one of it concurring and the other is parallel computing, for parallel computing, right? So SIM is a way to organize digital computers system for parallel computing. Okay, okay, which, so according to this, right? Each data point, um, a string, or yeah, a string is going to be processed. So in a string, in a string, okay, in a string, each data point, or character values will be processed, or in a string, each data point or each collection, or each, so the idea is, so the idea of SIM is for each data point, okay, is for one single instruction spread the processing unit per data point, right? Holy moly. Holy hell. Jesus, French stuff. Where we are going, bro? Where we are going? My God. Um, where we are going, bro? Where in the French toast we are going, bro? Exactly. Where we are going, bro? Mm-hmm. 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 The key insight is parallelism within a single instruction. One instruction operates on multiple data elements simultaneously. You know, instead of processing one byte character at a time, you process chunk of that, right? 18, 16, or even 32 in parallel. It is done using a special wide register. How V8 use SIMD for JSON stringify. Again, they're using is this sim, come from this paper, to say one single instruction, multiple data, aka we are parallelizing is computation. Given a single instruction, um, giving a single instruction with this huge amount of data, right? And we're gonna do that by chunk that. So right, take chunk of this and process them, right? In parallel, uh, in chunk of that. So how V8 use seems for JSON stringify, right? Traditional loop check one character per iteration, like this. I say, hey, I'm going to want this one, another one, another one, another one, right? When scanning string for characters that need scaping, the traditional approach will be like this. With seems, V8 does this traditional check one character. Exactly, the traditional is check one character, check one another character, and another one, and another one, and another one. But with sim, you say, hey, let's go to, instead of check one, we're gonna check now a chunk of that, and another chunk, another chunk. Holy fuck! The level and they using is now 16 because this is part of the UTF-16 Unicode, a way how you represents now strings on the computer, right? And in UTF-16 is because not only is ASCII characters or this West or English characters, but also you need to represent more than that across different cultures, right? The Middle East, the Southeast Asia, China, Russia, Mongolia, Africa, Latin America, North Europe, South Europe, Australia, India. You get the idea, right? So the two-level strategy from the V8 block. For longer string, use dedicated hardware SIM instructions. Load 16 byte into wide SIM register, and one instruction checks all those bytes simultaneously for special characters. And for shorter string, use SWAR, SIM within a register. Use clever bitwise operations on regular 64-bit register. Still process multiple bytes at one just without dedicating scene hardware. Mm-hmm. It's not exactly a spread the processing unit data points. It's more accurate to say one instructions operates on multiple data sets or multiple data points in parallel using a specialized wide register. The processing unit stays as one unit, but the instruction it execute is designed to handle multiple pieces of data at the same time, rather than one at a time. Holy moly. So the express lane of fast path, a faster double to string algorithm, and optimizing the underlying temporary buffer and the limitations. The new fast path achieve it is speed by specializing for common simple cases. If the data being serialized doesn't meet this criteria, V8 fallbacks to the general purpose serializer to ensure correctness. To get full performance benefit, the JSON stringify must adhere to the following condition: no replacer or space arguments. Providing a replacer function or space gap argument for printing are features handled exclusively by general purpose path. The fast path is designed for compact, not transform serialization. Plain data objects and array. Plain data objects and array. The objects being specialized or plain data objects and array. The objects being serialized should be simple data containers. This means they are their prototype and must not have a custom to JSON methods. The fast path assumes standard prototype like object.prototype or array.prototype. Don't have custom serialization logic. No. They don't have their own custom. Okay. They don't have. Must not have a custom to JSON method or serialization object. No index property or on object. So does functions have that? So function, will you create this object here to verify if I run this function state require a function, say hey, name, right? And if I want to call name, of course it's this one, but let me do this here of name. It is now, come on, for real. But I do want is the reference. Oh, you're not gonna show me the reference. That's lovely. that's interesting. Let's say console log. So call something here. Hello, right? You call this name. That's interesting. But I don't even. Oh, wait a second. Let's say is greetings, right? So I do have now this identifier, and it doesn't show the reference. That's interesting. Not even if I call it. It's not even calling this function here. Exactly, it's not even calling this function here. Or no, god damn it. There you got it. All right, makes sense. All right, yeah. Now you got it. It's this. All right. But does this function contains to JSON? To JSON? That's interesting. So if a particular object, so any object, so to JSON. So which objects have to JSON in JavaScript? That's interesting. Um, Several JSON object has two JSON method which is automatically invoked by JSON.stringify. To control how the serialization is, is serialized into JSON. Native JavaScript objects such as date implements to JSON, returning the same value to ISO string. Similarly, temporal. So for primitive wrapper types such as string, number, and boolean, although they are not standardized in ECMAScript spec, the toJSON method is also commonly implemented by custom classes to define how instance should be serialized, allowing developers to control the output of the JSON stringify. Okay, if you want to have control of that, of how now this is going to be serialized, okay, and how this is going to be serialized, and by serialization, a string representing the given day in the date time string for that. And this the toJSON method is automatically called by the JSON.stringify when the date object is a stringify. So if so anytime that you want to parse that, or any object that has that, it won't get the benefit out of that, right? Oh my god. No. And it all, oh my god, we get deeper into this. The fastpath assumes standard prototype like object.prototype or array.prototype that don't have custom serialization logic. No index property on objects. The fastpath is optimized for object with regular string-based key. If an object contains array like index property, like 0, 1, it will be handled by the slower, more generalized serializer. Simple string types. Some internal V8 string representations like constring can require memory allocations to be flattened before they can be serialized. The fast path avoid any operation that might trigger such allocation and work best with simple sequential string. This is sometimes that's hard to influence as a web developer. But don't worry, it should just work in most cases. The vast majority of use cases, such as serializing data for API response or catching configuration objects, these conditions are naturally met, allowing developers to benefit from the performance improvement automatically. Which is the two most common cases. Hey, I do want to catch this configuration, or serialize this data API response here, whether it's on the browser or on the server. By rethinking JSON.stringify from the ground up, from its high level down to its core memory and character handling operations, we deliver a more than 2 times performance improvement measure on the JSON Stringify Inspector benchmark. See the figure below for result on different platforms. These optimizations are available in V8 starting with version 13.8, posted by Patrick Tier. Holy fuck. And this is quite interesting. This is fast, bro. And this is fascinating, and it is practical for those two scenarios. When I want to catch some configuration, to serialize that, or to serialize is exactly by catching configuration is to JSON stringify and then store that locally, or by serializing the API response. Why I am doing this, and that's a very good question. That's a very, very, very good question. it all starts by asking three small questions, or by asking two questions, or by asking one question. Is that what is the performing way to look up for the data? What is it? What is the most performing way to um, show a JSON in an HTML element, and how do I what is the most performant ways to do data binding in the alternative here? Two questions. Holy moly, okay. Holy fuck. Okay. All right. Okay. Mm. Mm. All right. Okay. Mm. Mm. Mm-hmm. mm. Mm-hmm. Mm-hmm. Okay. So now I know that JSON Stringify for V8 engines has been, or its performance improved, the serialization process improved two times by using its SIM, a way of how you can organize digital computer systems for uh, giving a one single instruction parallelized data, or give, as you mentioned here. So one single instructions operates on multiple data points in parallel using a specialized register. Specialized now little boxes or buckets, right? So instead of processing your stream, so imagine that you are now, so when you're reading some content, right? You most of the time go one character on another, right? To actually understand the word, and then you go to the next word to understand more about the phrase and then the context. So imagine that you can now process, instead of one character, is one word, right? So it is somewhat similar to Chinese character base or hand base, like that. So when one character express something specific, and then another one and another complex stuff, and so on and so forth. Okay. Holy fuck. Mm. Mm-hmm. So this sim, single instructions, multiple data, right? Single instruction, multiple data, is a way for giving one single instruction uh, parallelize, or giving a one single instructions operates on multiple data in parallel using a specialized buckets, specialized register. Okay. Again, this is one of the computational architecture. Okay. Okay. Mm. 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 Again, the TLDR is that JSON Stringify is now using this way for parallelize multiple data points on one single instruction, the parsing, the stringify, using a specialized register. In this case, I think the using is a specialized hardware to do so. So holy moly. Mm-hmm. Mm-hmm. All right, that was for the first one, and that is, let's go to this, and let's go to call now update function. All right, or update, just like that. So let me call now this, or in this case, just like this. Right. So update is not gonna receive anything, and what it's gonna do is to parse this. Right. It's gonna call this update, and I'm going to receive is the data, right? This data is going to be now parsed using the JSON.stringify, right? Which is not an object. I will assume that this is an object. I must receive this an object, all right? And the result operation of this will be now is the element that I would like to update here, right? So you have now the object and you have now the element here. I can make this as it is. So instead of multiple parameter, one single parameter, that I'm going to receive this as an object, all right? And this element, it's gonna call this now the HTML element, or just simple, yeah, the HTML element to be more specific, right? Now that HTML element, that if I inspect here, is using this is the properties. I want that specific property, which is the inner HTML. No, is it text content? That's interesting. I don't have the text content here. What about text content? It comes from the node. Interesting. Okay, it comes from the node, right? Different from inner HTML. Don't get confused by the difference between node text content and HTML element instance. Although the names seem similar, they are important different. Text context get the context of all elements, including script and style. In the contrast, inner HTML only show human readable elements. Text contents return every element in the node. In contrast, returns every element in the node. In contrast, inner HTML is aware of styling and will return the text of hidden elements. So in other words, is parsing this. Moreover, since inner text takes CSS style into account, reading the value inner text trigger a reflow. Okay, the difference from inner HTML. And unlike the inner HTML, is now parsing into an HTML element. So to get or to set text inside of an element, because it deals with raw HTML rather than the plain text and can be susceptible to XX attacks. So cross-site scripting. Hey, somebody can now put a script and do some nasty stuff. Even if you are sure that the text never contains HTML syntax, it is still less semantic and slower because it needs to invoke the HTML parser. Start with the HTML fragment, and is this. You can use text content to get the elements text content. And let text document to get element by ID div8.textContent. The text variable is now this is some text. Document get element by ID div8.textContent. Okay, but this is part of the node. The node instance property and the node instance methods. So how can I get an instance? That's a good one. How can I get a node instance? The text content property of the node interface represents a text content of the node, and it is descending. So now you have the event target, all right, and that the event target follows the node. Okay, so this is okay. Mm-hmm. The DOM node interface is an abstract class upon which many other DOM API objects are based on. Okay. So you get now is the event target. Mm-hmm. 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 Relate page or HTML down. Mm-hmm. Mm-hmm. Element, node, and event target. Mm-hmm. Mm-hmm. Isn't? Mm-hmm. Let me ask Claude here. Isn't a way to mm-hmm. 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 Isn't a way to um okay. Mm-hmm. Okay. Isn't a way to uh uh I want to have a okay. Yeah, this is my problem. Okay, I want where where can I look at the how this is a very interesting question. This is the from the UML. Okay. Um, from the UML. Okay, in object programming, how can I mm-hmm, class diagrams for specifying structure, including data structures. Mm. Activity diagram for specify business process workflow, and components diagram for specify how components interface with other components, and deployment diagram for specify how components are deployed and executed on computational nodes. They use case diagrams for specifying user interaction with system, class diagram for specifying structure including data structure, activity diagram for business process, and the other is a component mm, meta modeling object the react link mm-hmm. UML2 define many type of diagrams show as a taxonomy. Mm-hmm. Class diagrams, components diagram, composite structure diagram, deployment diagram, object diagram, mm-hmm, package diagram, and profile diagram, behavior diagram, and interactions diagram. This is more like for the software uh, role here. This is a class diagram, an activity diagram. Conducting is a business flow. All right. Mm-hmm. The use case. Mm-hmm. Use case diagrams and the deployment diagram. Mm-hmm. So you have the database server that reads from the database interface that sits on the web server. It's shown at the presentation layer, and it keeps logs of all of these users, right? In 2013, UML has been marked by OMG for many contexts, but aimed primarily at software development with limited success. It has been treated at times as a design silver bullet. It has been treated at times as a design silver bullet, which leads to problems. UML misuse includes overuse designing every part of the system with it, which is unnecessary, and assumes that novice can design with it. It is considered a large language with many constructs. Some people, including Jacobson, feel that UML size hinders learning and therefore uptakes. Visual Studio removed support from UML in 2016 due to lack of use. Oh my god. But again, some of these concepts are still relevant, right? Some of these concepts are still relevant, and that is the C41 model. The C4 model facilitates collaborating visual architecture and evolutionary architecture in the context of agile teams where more formal documentation method and upfront architecture design are not desired. Exactly. Where more formal documentation methods and upfront architectural design are not desired. Mm-hmm. Context diagram, containers diagram. Decompose a system into interrelated containers. Components diagram, level 3. But in any case, because I can get lost quickly. I can get lost quickly, and that's not the whole point of this. The 4 plus 1 view model. Is this still being used? The logical view is concerned with the functionality that system provide to end users. The process view, sequence diagrams, communication diagram, activity diagrams, deployment view, physical view, and the scenarios. Okay, but I'm more interested here on the package diagram, components diagram, deployment, the process, sequence diagrams, communications diagrams, and activity diagrams, and the logical view. I'm more interested in this, in the class diagram and state diagrams. Okay, I'm more interested in the class diagram right now, right? I don't care about the others. Good for them. Not right now, right? Okay. So, where can I look at the class diagram of the HTML of the HTML of the HTML DOM API of the HTML DOM API, and it is subclasses. Please do your research, right? Mm-hmm. 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 Yeah, I do want to have a particular. If there is a website that help me to look up that, that'll be great. You know, that'll be French toast great. Because that's what I want. Is that hey, now it all begin with this object, and then some other objects inherit that. Mm-hmm. Why do I care about this? Well, because when I want to know what are the properties of these objects and what they describe and where they come from, that's what it is. I don't want to look up the MDN docs. I just want to understand once and for all why is this? Where is all of this coming from? Mm-hmm. Mm-hmm. You know what? Let me add some of it. This is another one. Que sale el sol al amanecer, sentado solo frente al mar, y yo sin Enjoy. Sentado solo frente al mar, bello sin amanecemos un sol, sentado solo frente al mar, y yo Sure. Sentado solo frente al mar, y es que yo. Exactly, JavaScript info. Official specifications define hierarchy through web IDL. What use what DOM living standard serve as the primary authority source of DOM interface relationship rather than UML diagram. It used the web IDL syntax, what is declared explicitly interface element node indicates of that. They don't use the UML, they use is now web IDL. living standard. Mm-hmm. This standard defines the interface definition language. Interface definition okay, that can be used to describe interfaces that are intended to be implemented in web browsers. Okay. Names interface, callback members, constant attribute operations, stringifiers, static attributes overloading. Okay, this is the interface that web browsers should implement. Okay. Namespace dictionary, exceptions, enumerations, callback functions, type def, type any undefined boolean, byte, octet, float. Okay, browsers must implement all of these interfaces. JavaScript bindings, environments, type mapping, integer, float, double, big int, dump string, byte, extend attributes, allow resizable expose, legacy extend, security, the platform model, interface object, legacy factory, name prototype objects, all of the interface that must implement constant attribute operations, stringify, asynchronous, iterable declarations, map like declarations, set like declarations. Okay, platform object implementing interface, set prototype, object observable, array exotic object, callable interface, invoking callback functions, namespace, exceptions, common definitions, even with functions. The function callback type is used to representing functions with no restrictions, void extensibility, legacy, privacy, ideal grammar. These sections define the LL1 grammar whose started symbols definition. Identifier, all of the numbers, string, white space, common, and others. Tokenizer operations and sequence. Document conventions. Conforms intellectual property rights. Index, term defined by the specification, terms defined by reference, normative, reference, informative, and IDL index. But again, it's describing what are the interface defined definition language. Web browser must implement. But web ideal syntax where inheriting is declared explicitly, interface element. Exactly, but they say interface element. Interface definition language. Interface, partial interface mixing, partial mixing definition, callback function, callback interface, namespace, partial namespace definition, dictionary, partial dictionary, type def include statement. Each definition matching definition can be preceded by a list of extend attributes, and so on and so forth. But again, oh my god, okay. This is the living standard of the web interface definition language. All right, indicates element inherent from nodes. Okay, so element, right? That I don't see that custom callbacks, invite stream, and element. You know, it says allegedly that elements interface element. So node, what about node? Interface node. Okay, but again, okay, okay. The following ideal fragment demonstrates the definition of two mutually referenced interfaces. Describe a version of the DOM interface. So the DOM. Now, but let's go way up to the top. Oh my God, there you go. Okay, let's go to this. DOM, base DOM exceptions, DOM exceptions, and DOM string, and DOM string, and DOM exceptions, and DOM exceptions, and the DOM string. But again, it's talking about the exceptions that these web browsers must implement for the DOM, the DOM stream, okay, and the other is the DOM stream, but for the JavaScript, right? A JavaScript value v is converted into an ideal DOM string by running the following algorithm. And the DOM string type corresponds to stream. Again, I don't see any of that node, by the way. You know? So if I check now, right up to the top. No, oh my God, what the fuck? What I did, what the? Reload. So if I say node, the first appearing is here, the DOM interface, DM interface. Okay, this is describing is the language here. Describing is the language here. Partial construction in this one. Oh my God. In web ideal standard web spec or define the formal syntax governing interface inheritance. Key rules include single inheritance only, no multiple inheritance between what and the include statement for mixing in additional functionality. For example, they may include parent node as the parent node. The Web3C DOM technical report now endorse that the WWED standard. Wikimedia historically document DOM level 3 core use OMG IDL but similarly lack visual diagrams. The WG standard, HTML standard here, extends its definition with the HTML specific element interface. MDN in JavaScript provides essential visual diagrams. MDN docs offer two key SVA diagrams a developer here, right? DOM structure.svg and HTML DOM structure SVG. The MDA event target page document the root DOM instance showing how elements document, and the MDN event target page document the root of DOM inheritance showing how elements document and window all inherit from event target. Exactly. Individual interface page node elements and HTML include inheritance information in their sidebar navigation. But this is from JavaScript.info. Provides arguably with the clearness, educational visualization at JavaScript info basic DOM properties according to this, right? Let's see if you are not. Um, let's see where it leads, right? Let's see where it gets. Let's see where it gets. Mm-hmm. Okay. No, this is exactly what I to develop an intuition about this. So all of this start with event target, right? The rule is the event target. When you look at the event target DOM here, okay, and that is inherited by node. Another DOM inherit from it. And here's a picture, explanations to follow. You got now the node, you got now the event target that inherit from that node inherit property from the event targets, and then now node has documents, elements, and character data. Mm-hmm. Right, and these elements now have all. This is okay. Makes a lot of sense. So if we are selecting an HTML element, so we are inheriting is all of the elements, nodes, and event target property. So far, so good, right? Okay, good. This is what I was looking for. Okay, now with this, uh, mm-hmm. Mm-hmm.
Si algún día te sentís mal o estás mal, tenés que venir a este templo. Este templo te da una paz interior te da este templo. Terrible la paz, la energía, la fuerza que hay acá. Por eso tienes que venir acá, a cualquier hora venir. Es en Avenida Independencia. Está entre 9 de julio
I'll be right back. All right, and we're back, right? Good. So, after knowing this is the inheritance, all right? Um, here we got it. This is all what I want, right? The DOM node class. Uh, According to this, he mentioned that from the DOM spec or the web IDL, the interface definition language. Good, good. All right. So yeah, this is how you can that. So you have the document and the document fragment plus the shadow DOM, which is something that it doesn't mention, right? But you can pull that out of that, right? You have now the node that has its document elements and character data. It doesn't include that. And 60 subclasses, right? So the character data branch handle text content and processing instruction, XML processing instruction, and all of this. So the event hierarchy enables rich user interactions handling. So you have now the event, the custom event, the clipboard animations, UI events, and all of these different user in event as it is. But TypeScript definition and the source IDL files provide complete API map from this HTML tag here. Oh, there you got it. DOM manipulation. It has its own. In the last 20 years since it is a standardization, JavaScript has come a very long way. While in 2020 JavaScript can be used on servers and in data science and even in the IoT devices, it is important to remember its most popular use case, web browser, which is this. Alright. And the DOM manipulation, the document interface. Okay. And the node interface, which is this. Alright. Difference between children's and child nodes, the query selectors and all query selector all methods, and this is it. All right, good. So now finally to what I really care about is, so I'm going to get is this HTML element that through this inheritance it have access to this property called text node, text content from the node, right? So here, what I can do is to or generate a new element and append that, all right? Or just update that HTML markdown. You say HTML update element, right? Or update HTML element, right? So you get this and you're going to mutate that element as it is. So HTML element, you got this text content, and that is going to be appended to. So if I run this anytime the, let's say, or at least initially, here I can say update HTML element, right? I'll be able to get that state here, right? That's right, because I need to pass is the element here. Let me hold this document here to say output HTML, right? Output HTML element, and that is, hey, document. If I go here to actually understand what are the properties that document inherit, it comes from node and the event target, right? So for the document, I want to query this document, which is document.get element by ID is one of the way to look up for elements that has an ID, particularly is the state display, All right. And that is what I'm going to pass to the output HTML element, but as an object here, the output HTML element and the pizza toppings. Toppings must be here. Toppings, right? So when this is executed, you're supposed to now update that particular element with the proper data. But this is a JSON like that, stringify, and that is what's supposed to pass a null and a just to get some format to prettify this. And here we got is this unexpected token here on cat, but there is nothing here. So it seems that this doesn't work. It seems that this doesn't work. All right. It seems that this doesn't work. I'm getting this element. I'm passing that. This is the HTML element or of the HTML content, right? I do want to call this here. It seems that it's not updating that despite that I'm passing this as a reference. Document get element by ID state display, right? If I want to know what this is outputting, if I take a look at the console, it says there is some unexpected token. I don't know why. Let me refresh this. Yeah, reload this. But with this piece of data, right? It says there is an unexpected token. Oh, is here. That's right. It's an unexpected token. So when now this is being evaluated, it's supposed to render that as it is. Okay. So when it called that, I actually do get that. It tells me, hey, text content does not exist, but you should have that. If I say text content, right, is let me clear here. If I say, let me render this. So this is the element here. So I can have access to that. Setting text content is a property is undefined. That's interesting because allegedly that exists. All right, that exists. That exists. So HTML element, right? Let me actually check the type of this. I think it's not gonna define what is this, but because it will say, hey, this is type of this. It will kind of call this object, so it's it's not very descriptive. I know. So the HTML element, it have the inner text. That's right. So it seems that this document query to get element by ID is not giving me what I expect here. It returns an element object, and if we take a look at this, elements should have that property, should inherit that, right? So interface returns an element object representing that ID, right? So this element here that I'm getting from, it contains all of these properties, right? I say text content does not, because if I take a look at the node, so text content is come from here, right? For some reason it say no, you don't have that access. Text content, right? So that node is not exposing that. So text content, right? It's a cannot set property of undefined setting text content. Can you show me is the previous example that you got here on the update display? You say document get element by ID, text content, and I do want is to stringify this. That's interesting. That's very interesting. State display and JSON stringify. So this HTML element that I'm getting here, and I'm passing that as an object, output HTML element. So that reference that I'm getting here, it's supposed to have the text content, right? Exactly, it's supposed to have is the text content. And you say JSON.stringify picks a toppings with null 2 as it is, right? But it seems that this doesn't work. What in the French toast? I am first getting this element, holding that reference here as an output HTML element, right? Passing is the data, and the structuring is this element. I'm assuming that they must have is the same name. Exactly. Alright, output HTML element, or in this case just HTML element. But I'm hearing just passing is the identifier. Here I'm getting is the HTML element. You can, if you take a look at this, supposed to get that HTML element, right? It say that this is now okay, it's undefined. It's undefined. That's interesting. So the reference that I'm passing when I call it is does not exist. That's interesting. HTML element is undefined, so it means that we need to preserve is the same name of the object expect, to hold the reference, as you wish, right? Where here you say is you can now rename this to say something like this. Alright, that's right. And now the HTML element that is gonna get is update that value and properly now show this as expected, right? You do have that, and you need to pass this, and now it's supposed to render there, but it doesn't. Okay. Oh, it's because the name of this. So you got, this is the data or the object. That's right. It was about mapping stuff. So now it worked as expected. Okay. All right. Okay. So far so good, right? So far so good. Okay. Mm-hmm. Okay. All right. That was the first thing to do. Okay. So I solved that particular issue. So I solved that specific issue. Mm-hmm. Mm-hmm. So what I solve is how do I show data here, right? How do I render data to avoid some common issues like XSX? Why you shouldn't use is inner HTML, not only because it's slower, but it unless you sanitize the input, you are parsing that HTML, you are parsing that text, which the browser is doing that for you, is parsing that text into an HTML, into a valid HTML. So AKA is parsing that and execute that HTML. So you don't want that because it's going to execute some malicious code if you pass, for example, like a script. So to avoid that, we use now the text content. You're gonna pass this as a string. So the browser is not going to parse this into an HTML. And this is because we can have access through to this property via the inheritance tree from the node, where the root is the event. Okay, the root is the event target, and from the event targets, document, node, and yeah, especially node. So nodes inherit this property and extend that to element, to document, element, and and character data. Then on character data, you can have is the text and comment, and so on and so forth. All right, it makes a lot. So now this image is helpful when you want to build now basic stuff like this, right? Okay. So now how do I actually is bind this data? So if you remember from the model, from the second model of user interactions in React, okay, and how we did these things before that, traditional way, the HTML, CSS, and plain old JavaScript, is by attaching now is a function to an event listener, uh, or by explicitly now call a functions on that HTML element. This now is what we are going to do. So, but there are several ways of how you can do right now. Okay. Mm-hmm. Okay. Is this one right? So whether you use the event-based approach, which you have now a single point to detect all of these events, and as long as it matches specific conditions, you are trigger this function. This is useful for you defining is field sets with a lot of these radio buttons and checkboxes, right? So which one of them actually triggered these events, and based on that, I'm going to now get the proper value and execute this function. to update the current UI. Okay, so this process is very imperative, uh, but again, this is how now the web works. Okay, using is this event-driven approach. The other, dig it, dig it, dig it. The event-driven approach. The other here is to bind to each one of those specific elements an event listener and detect that to update the element properly, right? So, in other words, yeah, there was an error here. Um, so data binding vanilla JavaScript, data binding vanilla JavaScript beat framework for 3 checkboxes, right? So whether you set this via topping checkboxes like this, okay, this approximately consumes 5 bytes of code versus 34 to 40k for framework with sub-millisecond response times per interaction, right? And then you have now the proxy-based reactivity for growing application. So the JavaScript proxy enables automatic DOM update when object property change, right? At a cost of roughly 20 to 30 times slower property access than vanilla objects. However, this translates to 3.6 million operations per second. Complexity imperceptible for checkboxes interactions. JavaScript proxy enables automatic DOM updates when object property change. So according to Complete Demolitions and NPM Web Docs, at a cost of roughly 20 to 36 times lower property access than vanilla objects. However, this translates to 3.6 million operations per second. Completely imperceptible for checkbox interaction. But again, doing this, so you define now the initial objects that you want to detect some changes, and therefore do something about. So update that property as it is. Create reactive toppings, which is you either set those topping here as it is, and then what is the functionality that you want to provide. View 3 adopt proxy over object.define property. View 2 approach, because proxy detects new property additions, handles array mutations natively, and intercept delete operations, none of which object.define property support. Framework overheat is measurable but rarely justified at a small scale. The Crosset JS Framework Benchmark 2024 reveals meaningful difference at its scale. Svelte 3 to 8 slower than vanilla, Vue 3 10 to 20% slower than vanilla, and React 25 to 40% slower than vanilla. Rich Harris, Svelte creator, document that virtual DOM is pure overheat. It is a mean to declarative programming. It is a mean to declarative programming, not a performance optimization. Svelte React Virtual DOMs diffin creates 7 virtual DOMs nodes just for the pixel topping components, comparing them on every state change before patching the real DOM. For 3 checkboxes, these microseconds difference are immeasurable. Frameworks overheat become justified when applications grow beyond 10 to 15 reactive elements, where the declarative pattern reduces bugs and improve maintainability. Most likely is this to reduce bugs, so you have observability of what's going on and when it changes, and of course the maintainability. Industry standards confirm these recommendations. to use text content. For that, Google.web emphasized the client-side rendering is more likely to generate long text that marks up DOM log from the server than a large DOM directly affects interaction next pane. And TC39 Signal proposed the future of standardized reactivity. The TC39 Signal proposed stage 1 as of late 2024 aims to standardize reactive primitive at the language level. Champions include representative from Angular, Vue, Svelte, Solid, React, and other major frameworks. The proposal defines signal.state from writable values and signal.compute for derived calculation, but remain experimental and subject to significant change before potential standardization. But practical recommendation for the Pixel topic, right? Which is define a common place to detect those changes, and therefore check that. So document query selector all the topping checkboxes, and for each one of them you want to verify that that has a check. You want to read that value and assign that, and then when that change, all right, you want to now is read the pixel topping and update that with that value. And this is it. So here you are effectively creating is a closure, because you are accessing properties, you're accessing identifiers, variables that are outside of the norm of the scope, okay? That are outside of the scope here. So effectively, you are closing over this function. And the same for this. Any identifier that is being used out of the for where it was declared, in this case is this function, you're not effectively are creating is a closure here. This approach delivers sub-millisecond updates, zero security vulnerabilities, and approximately 600 bytes of code. Frameworks become worthwhile only when application complexity grows significantly. The break-even point typically falls around 10 to 50 reactive elements where declarative patterns reduce cognitive load despite their bundle size overheat. So the key insights emerge from current specification and in its benchmark. First, text should be the default of any text update. It is faster than in HTML and immune to XX attacks by design. Second, proxy-based reactive offering excellent developer experience with negligible real-world performance, making it recommended pattern for applications that will grow beyond trivial complexity. Third, 24 and 25 industry consensus has shifted away from the virtual DOM is fast toward recognizing it is a programming model trade-off. Svelte compiled time approach and solid fine-grained reactivity now match or exceed virtual DOM performance while shipping less JavaScript to browsers. Virtual DOM is pure overheat. And understanding virtual DOM and why Svelte Solid.js opt-out. According to this, understanding virtual DOM and why Svelte and Solid.js opt-out. The core concept, document and the virtual DOM. So when set is called, React will re-render the component, producing a new state of the representation of the DOM. This with the new tree against the previous one, and identify only the text content would be the text content within the p tag that has changed. Update only the specific text node in the actual DOM. Why virtual DOM might be unnecessary? Svelte, the compiler approach. Svelte take a fundamentally different approach. It is compiler that transforms your component code into highly optimized imperative JavaScript code during the build step, rather than interpreting it at runtime. This means there is no virtual DOM at runtime. Of course, because it already generates this static representation of the code, or this the code that it is, that the browser can understand. Svelte components directly manipulate the DOM when state changed. This means there is no virtual DOM at runtime, and Svelte components directly manipulate the DOM when the state changed. Let's look at Svelte example for the same counter. You have this, the script, and then you bind to this. When Svelte compiles this component, it is essentially generate JavaScript code that looks something like this. Alright? It's generating it is code to actually keep track of that and so on and so forth. Right? So you have the P, you have the M, the D, the attaching, so attach the listeners, attaching listeners, updating element, if count has changed. There you got it. But again, it's generating now on like React that is generating on any create element is a new JSON object. Here is creating is a JSON. Okay. Here is creating is a new JSON that contains all the relevant information as well. Okay. As well as it is own data that it needs to. Oh, I will, but later on. Solid.js fine-grained reactivity, and is used now signal approach. The virtual DOM was a brilliant solution to the challenge of inefficient DOM manipulation, revolutionizing front-end development. However, as framework evolved, we've seen compelling alternatives emerge. Svelte and Solid.js demonstrate that by shifting work from runtime to compile, by shifting work from runtime to compile time, Svelte, or by establishing highly optimized fine-grained reactivity connection, the overheat of the virtual DOM and its reconciliation process can be bypassed entirely. This leads to smaller bundle size, faster runtime performance, and after a simple mental model for developers. These frameworks highlight that while the virtual DOM serves us well, it is not the only path and not necessary. But again, what are the performance here? Right? And this was actually quite. mm-hmm. Ship all of your ideas, website and online. You deploy your project for free. Docs and pricing. For deploying code. Mm-hmm. 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 Host and Next.js, site, Nox, Express server, yada yada. Run a Gene server, run Echo server. Mm-hmm. And 20 projects for free. Mm-hmm. All right, all right. Good, good. Uh, mm, mm. Exactly. Whether it's your binding events do that, um, but I will bind instead. So here you are binding instead event to each one of those elements. Okay, topping checkboxes, which is this, or binding here, because you either change that. This is 39 signal propose a future of a standardized reactivity. But that'll be all for this video. Take care. Bye bye.